Want to turn messy points into a predictive line? Meet linear regression and its heavy lifter, gradient descent. Linear regression is a simple supervised algorithm that predicts a continuous value from one or more features. The basic formula: y shaktoi r ratio plus v1 rx plus a sar intercept. The baseline value when x equals 0. Slope: how much y changes per unit x. A bit of error: the noise term a. The goal: find the line minimizing difference between predictions and actuals. Enter gradient descent. The optimization routine: it tweaks v0 and v1 to shrink that error. Here's how it works. Initialize parameters randomly, then compute the loss over predictions. Get the gradient, direction of steepest increase. Update parameters, opposite that direction using a learning rate. Repeat these steps until convergence. Batch gradient descent uses the full dataset. Stochastic updates per sample. Mini-batch mixes both for speed and stability. It's fast, efficient, interpretable, predicting house prices, forecasting trends, exploring relationships in data. It assumes linear relationships. It is sensitive to outliers. Wrong learning rate can make training explode or crawl. In short, linear regression draws the line. Gradient descent pushes it into place. Try it on a real dataset and see those points fall in line.